Exception handling in servlets. While we are developing an application, there are many chances for exception to be occurred. For example, here, while serving client requests, it will throw many problems like the requested resource not found, etc. So, for an application, exception handling is the must. Here are some of the ways to handle the exceptions in servlets. Using the web.xml file to handle exceptions and errors. Using a RequestDispatcher to forward the request to an error page. Using the sendError method of HTTP servlet response. Using web application log to record the exception messages. Using the setStatus method of HTTP servlet response to return the error slate to the browser. Here is a diagrammatic representation of different exception handling techniques in a servlet. Let's discuss one by one in detail. First one is using web.xml file. Here we can use the sub-elements of error page element in the web.xml file to handle the errors in a web application. We have three sub-elements in this element, i.e. the error code, exception type, and the location elements. If we are writing the servlets to handle the exception using the error codes, then we have to specify the error code element and the location element in the web.xml file. Here the error code is used to specify the type of error and location in the file that the container maps when the error occurs corresponding to this error code. Let's see a sample of web.xml file. Here we define the error code and location where it should be transferred if an error occurs. So if an error occurred, it's related to the error code 500, then the error.html will be displayed. Similarly, we can also define an exception type and the corresponding file location to execute when this type of exception occurs. Let's look at the codes in web.xml file. Here the exception type is java.lang.numberFormatException and location is error.html. The second method is using a RequestDispatcher. Here, if an exception occurs in a servlet, we can use the RequestDispatcher to forward the request to the different resource. Most probably it will be an error page. We have already discussed enough about the RequestDispatcher, so we will see the next technique. Using the sendError method of HTTP servlet response. Here, we can use this method to send an error page to the browser. The code that uses this method will be like this. Here we can send the string message in sendError method to tell information about the error. If the error code corresponding to this type of error has a mapping file, then the string message can be ignored and the file will be executed. The next one is using web application log. Here we can handle the exception using the log file present in the web application. If an exception occurs, the exception event can be added in the log file. The log method is available in generic servlet and servlet context class. For example, we can use the log method of the servlet context and the code will be like this. Here the getMessage method will give a message about the exception. Last method is using the setStatus method of HTTP servlet response. Here the servlet can handle the exception by using the status codes to indicate the status of the response. This method doesn't generate any error pages, it just sends the status code to the browser. The setStatus method sets the status code. If the response is already committed, then call to this method has no value. Default status code is 200. OK. We have already discussed about the status codes. Here are the 5 general categories of the status codes. They are 100 to 199 indicates informational. 200 to 299 indicates successful. 300 to 399 indicates redirection. 400 to 499 indicates incomplete or file error. And 500 to 599 indicates server error. Here now is an example code that shows the setStatus method, setting the status for the resource that requested that was permanently moved. I advise all of you to practice these techniques in your servlet programs, because these exception handling techniques play a significant role in real-time applications. So up until now we've had a brief discussion about the exception handling techniques in servlets. I am sure that it will surely help you while you are developing the applications. Thread-safe servlets. So far we've seen the various functionalities of servlets and many servlet programs. Now we'll discuss about one of the interesting topics, i.e., thread safety in servlets. We can make the thread safe servlets by implementing the single thread model interface. Let's look on single thread model interface. The servlet implemented this interface ensures that no 2 threads will execute concurrently in the servlet service method. The single thread model interface does not define any methods. The servlet container promises this by either synchronizing access to a single instance of the servlet or by maintaining a pool of servlet instances and dispatching each new request to a free servlet. The servlet XXX implementing this interface has this form. Here we are seeing the figure that servlet services the client requests. Here Servlet 2 implements the single thread model interface. Now 2 clients requests arrive for Servlet 2. The container uses a different instance of Servlet 2 to service each of the 2 requests. If the container doesn't have more than 1 instance, it services these 2 requests one by one. However, this technique has its own disadvantages. If the access to the servlet is synchronized, the requests get serviced one after the other, which can cause a severe performance degrade. Another thing is maintaining multiple servlet instances consume time and memory. Implementing single thread model does not ensure that the servlet is thread safe. Here still the static variables attributes stored in session and context scopes are shared between multiple instances. Let's look on the thread safety of variables and attributes. First, consider the local variables. Local variables are always thread safe because each servlet has its own copy of these variables. They cannot be used to share data between threads, and also their scope is limited to the method in which they are declared. Next, instance variables. Instance variables are not thread safe usually, but in case of servlets implementing single thread model interface, they are accessed only by one thread at a time. Static variables. Static variables are never thread safe. These variables are at a class level, so they are shared between all instances. These variables are not thread safe even if the servlet is implementing the single thread model interface. Because of these characteristics, they are usually used to store only constant or read-only data. Context scope. The servlet context object is shared by all the servlets of a web application, so multiple threads can get and set attributes simultaneously from this object. Here also, implementing the single thread model interface does not make any difference, so the context attributes are not thread safe. Session scope. HTTP session object is shared by multiple threads that service the requests belonging to the same session. The session attributes are also not thread safe. Request scope. Servlet request object is accessible only locally within the service method. The request attributes are always thread safe. We can also develop the thread-safe servlets using synchronization. Here, we can use these in two ways. They are synchronizing the block of codes that access the shared resources like this. The second method is synchronizing the methods that access the shared resources like this. Well, here we are now finished our discussion on server safety in servlets.